Hi, I've got a couple of examples on how to calculate sample size, and we'll be done. So this information is on page 364 in your book. It would be good if you would go look there. Calculating sample size with population proportions and sample proportions is similar to calculating them with means and standard deviations of populations. So we're to find the sample size necessary for a 95% confidence interval, a margin of error of 0.04, and a sample proportion, a p-hat value, of 0.78. So there's a formula for this. That is, n is equal to z squared times p times q over the margin of error squared. So 95% means we have 5% left over in each, or to be shared equally in each tail. So using Desmos or your calculator in an area of 0.025, we get a z-score of 1.96. Our sample proportion is 0.78. Our q-hat value then is 0.22, and our margin of error is 0.04, and we get 412.01. And just like previous sample size problems, you always round up. So it rounds up to 413. Here's another example. And this example has some phrasing in it that you'll need to look on page 364 for. But most conservative estimate, we want the most conservative sample size, the smallest sample size, for a confidence interval of 98% and a margin of error of 0.025. Well, if you notice, there's no percentage, there's no sample proportion included here. And that's because most conservative estimate is another way of saying we want the probability of success in a way, our p-value, p-hat value, to be the same as our q-hat value, which means both p-hat and q-hat are 50%. So we have our formula, n equals z squared times p-hat times q-hat divided by the margin of error squared. So 2.33 is our z-score because 100% minus 98% leaves us 2% to be split evenly in the tails. And using Desmos or your calculator, and the area of 0.01 gives us a z-score of 2.33. Most conservative leads us to a p-hat value of 0.5 and a q-hat value of 0.5, and our margin of error is 0.025. So 2.33 squared times 0.5 times 0.5 divided by 0.025 squared gives us 2,176.56, which always rounds up, and we're going to round up to 2,177.